Hello class, I'm going to discuss to you about finding the vertical and horizontal asymptotes of rational function. Okay, so let's proceed. So let us define first what is an asymptote. Okay, an asymptote is an horizontal or vertical or slanted line that a graph approaches but never touches. Okay, if you're going to take a look at our figure, we have here the horizontal asymptotes, okay, the dashed line, no? And also we have the vertical asymptotes ito. Okay, so take a look at the graph. It will never cross the asymptotes, because that is the boundary already, but it will be closer and closer but never touches or crosses. Okay, and so let's proceed. Now, how to determine the asymptotes? Okay, determining asymptotes is actually a fairly simple process. Consider the rational function. All right, so we have here the function. So take a look at the m and n. Okay, so we will be basing our solutions in those exponents. All right, next. So steps. The graph will have a vertical asymptotes at x equals a if the denominator is 0. And x equals a, I mean at x equals a, and the numerator isn't 0 at x equals a. Okay, so number two, if n is less than m, then the x-axis is the horizontal asymptotes already. And then if m um, equals m, then the line y equals x or a over b is the horizontal asymptotes. If n is greater than m, there will be no horizontal asymptotes. So I repeat, if you have here n less than m, okay, then the x-axis is the horizontal asymptotes already, or y equals 0. Okay, but if we have m or n rather equals m, they're equal, you just consider the coefficient of the numerator and the coefficient of the denominator. And then if n is greater than m, there will be no asymptotes already. Okay, next. So let us take a look at this example. Okay, we have f of x equals 5 over x plus 3. Okay, so the vertical asymptotes, now all you need to do is just consider the denominator. All right, which is x plus 3 equals 0. Okay, equate that to 0. Then just transpose that. X now will be equals to negative 3. So this will be our vertical asymptotes. Right? Now, the horizontal asymptotes. So let us take a look at the numerator. It is a constant. Therefore, um, the n or the exponent is already none or 0. Okay? Then we have here in the denominator, the exponent of x is 1, right? So therefore, the n um, is less than the m. Okay, meaning this is bigger or higher, has a higher exponent than the numerator. Okay, because this one there's no exponent. Okay, so therefore, um, y is equal to 0. Okay, so that is our asymptotes. Okay, next. Okay, example number 2, we have here a rational function again, 3x over 4x minus 8. So let's take a look at or determine the vertical asymptotes. So consider the denominator 4x minus 8. Equate that to 0. Okay, so transpose the negative 8 to the other side. So it will be 4x equals 8. Divide both sides by 4. And then, ayan na. x now will be equals 2. So this will be the vertical asymptotes already. Okay. Now for the horizontal asymptotes, we have here um, we need to determine, okay, the n and the m. Okay, so take a look at the exponents here. At the numerator, which is 1, the exponent is 1, or highest exponent is 1. Here at the denominator, the highest exponent is 1 also. So therefore, they're equal, right? But if they're equal, we need to consider the leading coefficients. Okay, so we have here the 3 and the 4. Okay, which is 3 over 4. So this will be our horizontal asymptotes. Okay. Okay, so let us do example number 3. So we have here a rational function again, 2x minus 3, then x squared minus 5x plus 6. But first, I will factorize the denominator, okay? The numerator, I just copy 2x minus 3. And then the denominator, I can factor that. All right. So what is the factor, or what are the factors of x squared? So I just have 1 x times x. What are the factors of, so I'm done with that. What are the factors of 6? So factors of 6 can be 3 times 2 or negative 3 times negative 2. Okay, so I need the negative because if I'm going to add, it will become negative 5. So negative 2, then negative 3 here. Okay, then I can now determine the vertical asymptotes. Okay, so I need to get the first factor, which is x minus 2. You just equate that to 0, then transpose it to the other side, so it will become x equals 2. Okay, so this is the vertical asymptotes. And the second one is x minus 3. You equate that to 0 again, transpose. So x now will be 3. So we have two asymptotes, okay, or vertical asymptotes. And for the horizontal asymptotes, okay, consider again the n and the m, okay. So take a look at the leading coefficient, or the highest exponents in the numerator and the denominator. So the highest exponent here is 1, okay. 1 is the highest exponent. So therefore, the n, okay, is less than the m. Mas malaki yung nasa ibaba, okay. So if we have a bigger exponent or higher exponent at the denominator, so therefore our horizontal asymptotes is y equals 0. Okay. Next, so we have here the last example. Take a look at the rational function again for x raised to 3 plus 3, and then the denominator is x raised to 2 plus 3x minus 10. Okay, so again, I'm going to factor out the denominator because I know that I can factor this out. In the numerator, I cannot factor that out anymore, okay? So plus 3, I'll just copy it. So this one at the denominator, I can again factor this out. Factors of x squared, x and x. And then negative 10, I can have here negative 5 and positive 2. So if I'm going to subtract that, wait, I need to make this one positive, this one negative. Okay, because if I'm going to subtract or add 5 minus 2, it will be positive 3. Okay, so I already factored that out. Then I can now determine the vertical asymptotes. I will consider first the x plus 5. Okay, x plus 5 equals 0. Equate that to 0. Transpose. So x now will be negative 5. So this will be the vertical asymptotes. First vertical asymptote. The second, I have x minus 2 equals 0. Transpose again. X now will be 2. Okay, so I have two vertical asymptotes. Okay, x equals negative 5 and then 2. What about the horizontal asymptotes? Consider again the n and m. Okay, so this one is our n and this one is our m. Okay, considering the highest exponents of numerator and the denominator. Okay, so n is greater than m. Mas malaki yung exponent ng numerator, 3, than the denominator, 2. So therefore, no horizontal asymptotes. Okay, no horizontal asymptotes. Okay, asymptotes. All right. Yan. So that's it for um, our lesson and how to determine the vertical and horizontal asymptotes. Thank you.